So far, we've focused on server TLS. Now we're shifting to certificates issued to users and domain-joined computers. You'll see how they prove identity, where their keys live, and how renewal, expiration, and revocation are managed across Microsoft environments. You've already built a complete PKI stack, from cryptographic fundamentals to a working AD CS deployment in Azure that secures IIS and RDP. Now we'll zoom in on user and computer certificates as identities that drive authentication and enterprise access control. User and computer certificates act like digital ID cards backed by cryptography. Each certificate binds an Active Directory identity to a specific key pair and a template that defines what it can be used for. Fields like the subject, SAN, and EKU describe who it represents and which scenarios it's valid in. Issued through AD CS and auto-enrollment, these certificates enable strong authentication and device trust without constantly managing passwords or manual trust settings. A user certificate functions as a digital ID that your systems actually trust. It can be used to sign into devices, VPNs, Wi-Fi, or apps without relying only on passwords. For email, SMIMIVE lets you prove you sent a message and keeps contents encrypted. Stored on a smart card, it enables strong physical sign-in. Altogether, it raises confidence that the user really is who they claim to be. Computer certificates are all about proving the identity of a device, not a person. With machine authentication, a laptop or server can log on to the domain even before any user signs in. Domain services rely on this to trust which hosts they're talking to. Network gear for VPN or Wi-Fi can challenge the device certificate before granting access. Internal TLS also uses these certificates so servers encrypt traffic and mutually verify each other. Certificate identity is really about how the PKI represents a user or computer stored in Active Directory. The template decides which AD attributes flow into the subject and SAN fields. For users, that's often the UPN, so certificate-based authentication can be tied back to their AD account. For computers, it's usually one or more DNS names, so clients can validate they're talking to the correct server or device. Certificate templates are where you decide who can get a certificate, what they can do with it, and how safely it's handled. Enrollment and auto-enrollment permissions act like a gate. Open them too wide, and anyone can mint powerful credentials. EKUs limit what a certificate can be used for, while subject naming and private key export settings decide how closely it's tied to a specific user or machine. When these settings are misaligned, they often become your biggest PKI security gaps. There are really two ways to get certificates into your environment. Manual enrollment is hands-on. An admin or user requests a specific template, gets it issued, and the certificate lands in that user or computer store. That's ideal for testing, lab work, or tightly controlled scenarios. Auto-enrollment is policy-driven. You configure and publish the template, set permissions, link a GPO, and clients silently enroll as users or computers. Windows actually has two separate certificate worlds. User certificates live in the current user store and follow that user's profile. They're used by apps running as that user, like browsers or email clients. Machine certificates live in the local computer store and belong to the device itself. Services and system processes typically read from this store. When troubleshooting, always match the application's security context to the correct store in MMC. A certificate is only useful if Windows actually has the private key. So as an admin, think in terms of a quick checklist. First, is the certificate present and trusted, with the right EKUs? Next, does Windows show that a private key exists and that permissions allow your account or service to use it? Finally, check whether the template allows key export. If export is enabled and you create a PFX, treat that file as highly sensitive and store or transfer it securely. When a user signs in with a certificate, the certificate is effectively their password. The service first checks whether it trusts the issuing CA and that the certificate is valid, not expired, not revoked, and allowed for client authentication. Then it reads the identity data, like the UPN, and maps that to an account in Active Directory. Only when both validation and mapping succeed is access granted. Computer certificate authentication is all about the device proving, "I am who I say I am," before any user signs in. The machine presents a certificate tied to its computer account. The service checks the issuing CA, the full chain to a trusted root, expiration, and revocation. It also verifies identity details like DNS name or device ID, and that the certificate is allowed for client authentication. If everything checks out, the device is trusted and access is granted. Imagine a domain-joined laptop connecting to corporate Wi-Fi using EAP-TLS. The CA issues user and computer certificates from templates, and group policy automatically enrolls them. When the laptop connects, the Wi-Fi controller forwards authentication to NPS. NPS validates the presented certificate. It checks the issuing CA is trusted, the EKU allows client authentication, and the certificate hasn't been revoked. Only after those checks pass is network access granted. We've looked at what user and computer certificates can do. Now we need to think about how they're actually run in production. Operational discipline is what turns strong crypto into real security. That means controlling who can enroll, locking down private keys, putting certificates in the right stores, and planning for renewals and revocation. User certificates give people identities for logon, email protection, and smart card use. Computer certificates give devices identities for TLS, VPN, Wi-Fi, and domain trust. Both depend on the correct certificate stores and strong private key protection. Next, we'll look at renewals, expirations, revocation, and CA backup and recovery.